In this video, we're going to create a 2D player character. You will learn about key Godot nodes like Area2D, Animated Sprite 2D, and Collision Shape 2D. By the end, we will map keyboard inputs, handle basic animations, and make our player move in 4 directions. First, click Other Node and search for Area2D. We are using Area2D because it allows us to detect when other objects like enemies or coins overlap with our player. Once created, double-click the node and rename it to Player. Now, we need visuals. Add a child node to the player called Animated Sprite 2D. You'll notice a warning icon. This is because we haven't set up the animation frames yet. Go to the inspector on the right, find Sprite Frames, and select New Sprite Frames. Click on it to open the animation panel at the bottom. For this tutorial, I'm using the assets from the Godot Dodge the Creeps documentation. We need 2 animations, walk and up. Drag your walk images into the walk animation and your up images into the up animation. You will see another warning next to the player node. It needs a shape. Add a child node called Collision Shape 2D. In the inspector, set the shape to Capsule Shape 2D. Before resizing the shape, click the Group Selected button, the icon next to the lock, on the player node. This ensures that if you move the parent, all child nodes move with it. Now, adjust the capsule shape to cover the sprite properly. We have a player, but we can't move it yet. We need to map our inputs. Go to Project Settings, Input Map. Add 4 new actions: move up, move down, move left, and move right. Assign the corresponding keyboard keys to each action. Select the player node and click the Attach Script icon. In the script, you'll see the process function. This function runs every single frame, so it's where we will handle movement. First, create a variable called velocity and set it to vector20. This means the starting speed is 0, 0. Now, let's check for input. If move right is pressed, add 1 to velocity x. If move left is pressed, subtract 1 from velocity x. If move down is pressed, add 1 to velocity y. If move up is pressed, subtract 1 from velocity y. Wait! Why subtract for up? In Godot, the y-axis is inverted. Down is positive, and up is negative. Now, if the velocity changes, we need to play the animation because the user clicked some key. Since our velocity is just 1, the player would move 1 pixel per frame, which is too slow. Multiplying by a speed variable makes it move at a usable pace. Also, if user didn't press anything, we can stop animation. Now we need to update the position. Delta represents the time it took to complete the last frame. If a computer is slow, delta is high. If a computer is fast, delta is low. By multiplying by delta, we ensure the player moves at the same speed in the real world, regardless of how fast the computer is running. If we run the game now, the player can walk off the screen. To fix this, we use the clamp function. We restrict the player's position so it stays between 0, 0, and the screen size. Finally, let's polish the animation. If velocity x is not 0, play the walk animation. If velocity x is less than 0, moving left, set flip h to true. If moving right, set flip h to false. Do the same for velocity to y using the up animation and vertical flipping. Let's play the scene. The player moves smoothly in all directions, the speed is consistent, and the animations flip correctly. You now have a fully functional 2D character controller.